Thank you all to having me today here. Nice people, nice location, I'm happy. And today I want to speak about the agentic AI in the claim processing and much more in the car damage evaluation. But before to start, I want to introduce myself. I work with numbers, with uncertainty and risk. I'm an actuary during the day. And I play with data in the AI and data science in the free time. Okay, look at the agenda. It's really rich. We start with the motivation, the use case introduction, and we go also with the demo. So the motivation is coming from many years ago, not many, but maybe 6-10 years ago, and about the whole idea to develop an deep learning car damage classifier. The idea was simple, to use an app to upload the image and with a binary classification or the multi-classification, depending on the damage part, and also to annotation with the repair cost. What is the issue? Issue that there wasn't the dataset with the labels and also with the annotation cost. So I shoved the idea. But some months ago, this idea came back me in mind because I thought about the use of the agentic AI. Okay, this is the state of art about some years ago when I had the idea of develop the app with the deep learning classification. So I found this Streamlit app, and they are based on binary classification, multiple classification, or otherwise with some parts with scoring, but something about guessing. So if you look about the claim processing, is really slow. Because it starts with when you have a car accident, the customer gives the notification and submit the documentation. Then there is a claim handler that for the claims to investigate about the fault, the evaluation of the cost, and there is also the approval about the claims, and then there is about the communication and the reimbursement about the payment. So the claim processing can be for 2-3 weeks for a simple claim, or otherwise add more than 1 year for litigation claims. So the idea of what can be is if you use an agentic AI, you can really become your claim processing faster with the data-driven process. But before to start to talk about the agentic AI, the revolution is coming from the transformers, yes. Because years ago, from the communication, the paper, attention is all you need from Google in 2017, these transformers changed everything. The idea is brilliant because data are not processed sequence to sequence, but at once, with attention mechanism that give the weight, give the much importance, what is the part of data matters to each other. In this way, you can take about the long-range dependency between data. The modern language models are using transformers, yes, different from the first used for translation, and are similar, for example, for the GPT for the text generation to create responses, text responses. The revolution for the computer vision is coming also from transformers, because transformers is flexible, and you can use transformers also for visual language models. Just to use a visual encoder that capture the images, create the visual features. This visual encoder is trained on large image or text data in image, and create these visual features. Then there is a projector that is a bridge between this visual encoder and the transformer. This projector map the visual features into the embedding language with the image tokens. In this way, the transformers have the same embedding with the image tokens for images and text tokens for the text, and can process both. So this is the idea for visual language models that can be now the state of the art for the computer vision. But what happens if you give to your visual language models or language models the possibility, opportunity to act, to interact with the environment, became an AI agent. So an agent is a system where is able to perform a task, complex task or simple task, in one given by reasoning, by the planning, by the action. So it starts with the perceiving, with the perception, retrieving the information from the external environment, then reason and reason about the act to do, the decision to do, to make do, and in this way is handled by the large language model or visual language models. And then with the action interact with the environment, just calling some tools such as APIs or other querying database or something else. At a layer up of this, there are the planning that the agent can plan, breaking down the complex tasks in a subtask, and also is able to give the priority each step. Also, there is the memory and the knowledge, and with this memory and knowledge, they contain the retain the context of the interaction, and for some agent, there is opportunity also to learning with some external knowledge. So why the use of the agent? The use of the agent is why, because they are able to give some complex task or repetitive task in an autonomous way, without the human intervention. So they are also able, with the tools, to adapt to the context. And in this way, given that they are able to give some repetitive task, they are improve the augment the human knowledge for brainstorming, for problem solving, for automation, and they can be used for repetitive tasks to increase the productivity, leaving people with into high level activity, much more efficient, much more important activity. So improve the efficiency inside the company. And also for the customer is able, with the knowledge, with the external knowledge, can be also memorize some personalization, so give some personalization experience for the customer. So there are many opportunities to use agent. There are different type of agent, just the two extreme. One is using a single agent. In this way, you have one agent that give the whole task, but it's easy to realize, but it's less scalable. But instead, on the other side, there is the agency. There, with the agency, you have multiple agents that work, that collaborate. In this way, they are processing much more information, and they are really good in the company. But the problem is coming from the coordination. So what I realized an app that and the stack that I use is coming entirely with using the Python framework. I decided to don't use any external framework for one reason. Okay, you have iStack, you have LangChain, LangGraph, you have Crui, Payouts, but you have some strict framework. So with Python, you have governance on everything. You done so you're free, and you are not linked with the external break change. So for the company, it could be good because you have a stability, and you are easy to implement, and also you can grow in your implementation. And the others are framework, the API, OpenAI and Perplexity. OpenAI for the Vision agent, and Perplexity for the cost agent and the final shop agent. The deployment happens on Hugging Face, so for this reason my first choice was Gradio, and okay for the backup Streamlit. Okay, before to start with the demo, we just an introduction. Okay, I started months ago just for a simple pipeline with based on the function, the call API with OpenAI and Perplexity for this type 3 type of agent. The Vision agent, the cost agent, and the shop finder agent. But it was easy, so it didn't adapt to the context. So I thought about something much more debuggable, much more auditable, and I thought about to use the agent system. With the agent system, but thought in this way, creating the React loop: reason, action, and observation. With the reason, okay, you have the first state, react thought, the agent state. There is what happens that the agent in this way think about the decision to make. Then there is a action. So with the reaction action, the agent decide which function to use. With and then there is the action FN. That in this way it works, because in this way call the API and retrieve the data, the raw data, and with observation there is it sees the data. They are registered in the logs summary. So each agent have internal state with a Python dictionary. With and when you start your agent, you call with the create state agent state with the type of agent and with the configuration. In this way, you have an agent that is explainable. You have a self-tracking with the direct trace, and also is stateful because you have every state. So this is the architecture of the app. You upload the picture with the location. You have this information go to into the orchestrator agent. This orchestrator agent map everything. So this plan each step of each agent. Each agent works sequentially. There is the vision agent. This is the first that analyzes the images and provide detailed information with the damaged parts, also with the classification of the severity, minor, moderate, or severe. This information does into the context and arrive to the two cost agents. In this way, they have there is the dealer service and the independent shop. Why two cost agents? Because I don't have a data set, so I use only the picture from Kaggle. And what I've trusted about the cost, the estimation of the cost. Using two cost agents, I have the opportunity to have a comparison, because this estimation coming from web. And then there is the shop finder that it was looking about the from 3 to 5 shop location, shop repairing cost into the location, and then these information are grouped and then for the output in a Streamlit or Gradio interface, user-friendly phrase. Okay, now I start with the app, okay, the demo live, okay. You can see this is the Gradio app on Hugging Face. I written the API, I upload an images, and I put the location. Just you push the button. Okay, it takes just less than minutes, 50 seconds, so it's really quite fast, but because there is just one loop, and it's I think that it's a really good achievement for the customer, also for the worker, because it can be used both for the customer and both for the worker. So you have first of all, you have the damage analysis. In this way, you have the description of the damage analysis. You have the affected part in this way, okay, the head, bonnet, front grille assembly, left half map assembly, right hand map assembly, so on. And you have also the classification. In this way is several. After that, scrolling down, you have the two comparison about the range of the cost, and for each cost there is also the breakdown of each component. After that, also there is a shop finder. We have the description of each repairing shop with the details, okay, and there are address, phone number, website, maybe, okay, depends. And okay, in this way also we have at the end the React trace. That is the nice things of this app, because we look about. For instance, we start with the orchestrator, the thought. We have received inputs with image, yes, and location Munich, Germany. I need to determine which agent to activate in what order. The action is a build execution plan. So observation, we have the execution plan built with 4 steps: vision, cost, primary, cost alternative, and shop finder. thought I have a plan with 4 steps. I will execute each agent in priority order, vision first, then cost estimator, then shop finder, passing results downstream and context. Action, execute agent plan is the function. Observation, all 4 agents, task completed, vision, cost, primary, cost, alternative, shops. For the vision agent, we have the thought, I have received a car damage image. I need to call the vision model to identify damaged parts, assess the severity, and extract a structured description. The action is the call OpenAI Vision API. The observation is a Vision API responds successfully. Detected severity, severe, confidence 78%. Cost agent, we have the 2 cost agents with the thought, I have damage information with severity severe, and I need to generate a detailed estimate for the primary repair philosophy in Munich, Germany, using euro. I will query the Perplexity API with the structural requirements. The action is a call of the API, Perplexity API. The observation is the cost API. The primary responded successfully, estimated the range. The same for the aftermarket, and also the shop finder agent. Yes, okay, the thought, I need to find auto body repair shop near Munich, Germany. I will require Perplexity which structural request for shop names, addresses, rating, and the contact details. The action, you have the call the API, and then the shop, the observation is the shop search API responded successfully for location Munich, Germany, retrieved a shop listing 3 section found in response. So this is the app that I've realized. We come back to the presentation and to the slides. So this part we have just watched about the demo. But just to have a comparison between the generative AI, the agentic AI, and tools using about convolutional neural networks. So the transition, what happens? Okay, with the if you think about the convolutional network, you have a in terms of generalization. If you want to you change your task, you have to retrain your model. If you have your goal is only to make a classification, single classification, binary or multi-classification, single task. So is not adaptable with the adaptability with the new prices require new training. And also about the explainability is a black box. And also they are monolithic scripts, so the entire pipeline, if you change something, you need to retrain. With the agentic AI, with this model, what happens? And first of all, yes, you have the reason patterns. So you have something with the React loop. You have a trace about your you have a trace of your reasoning, and also you have a description, you have a language description, so it's much more. Also for the goal, you have end-to-end assessment, much more tasks, so you have a reply to much more questions, the cost, the analysis, the cost, and also define the repairing shops. And also you have much more data update with the market, because you have web search data from the market. Is considered transparent because you have the description of each action from each agent. And also from the modularity, you can switch each step, each specialized agent replace with also with the convolutional neural network, for instance, or you can add other stuff, other agent. On the other ways, there are some constraints. For instance, yes, your estimation is approximation because I haven't a data set, so it required, for instance, for this cost estimation is coming from the web search, so it's necessary the professional man, so human in the loop. Then also depend of the quality of the image, because if the image is blurry, yes, your estimation is bad. And okay, you don't have, for instance, your static. I don't have a static database. In this way, what happens? That the data is not guaranteed from this static database, so it can be used, for instance, it can be implemented a database for a comparison, because now I'm using only market search. And then for about the regularity, the insurance world is much more regulated. Yes, there is the app is auditable because you have the trace of each agent, but maybe for the put in production requires other alignment. So what I've learn from this experience. Building from scratch is important because you learn how it works, the ecosystem, and also it's possible to realize, for instance, a multi-agent system. This app can be used as a starting point for the claim processing, and maybe can be used as the initial process, then building from scratch before to transition on external framework, because at the moment the external framework are unstable because they are changing a lot. Also, what is the opportunity from the multi-agent system? The opportunity is that you can break down your complex tasks, such as claim processing, into sub-tasks, and then you can create end-to-end pipeline. And then, okay, you can create your multi-agent system not only with the specialized agent, but also using different brains, using so different type of language models, visual language models. I used OpenAI and used Perplexity for different tasks. Okay, there are the reference, and that's it. Thank you.
Thank you very much for your interesting talk, Claudio, and thank you for asking questions. If you have more questions, you can access here talks.pycon.de and ask them right now. We have a little bit of time, and the first question
look. So, okay.
From the audience is, how do your agents calculate confidence scores? For example, calculating confidence and uncertainty scores of a multi-classification task in the image detection is a statistical challenge that vanilla agents are not capable of.
Exactly. This is important, this question, really good question, because I thought about the confidence. What happens? This confidence is given by the system, retrieved by the agent. So is not, I'm not able to check about how is it calculated. This is a black box point, but it's important. I consider to use the confidence for one reason. Because with confidence you can understand how your result is good, and for instance, for in next development, for to give a next step in the pipeline. So yes, that good question, because you building a deep learning model, you have the framework that you can build your confidence. Here is external confidence.
Thank you. The next question. How do you quality assure the proposed multi-agent system?
Okay, it's difficult because good question, because the problem exactly is that I don't have the data set. Welcome if something want to propose a data set with the database with cost, and when we can have the quality assurance, quality evaluation about the multi-agent app. I created the two cost agents for instance, to have a comparison, and but yes, a good quality is coming from a benchmark, and I have to create some that is working with this type of data is welcome to give the help for a comparison.
Thank you. The next question is, how do you leverage insurance conditions documents? For instance, how would you decide coverage determination using LLMs?
Coverage determination. Okay, here there are not about the documents. This app is just about evaluation of the picture and the location. So how it can work? It can work at you have the app, the customer, also the worker, upload the picture. Is just for one picture, but you can upload many pictures, can realize, and with the location you have evaluation. It can be extended with, for instance, if you think about the MSCP server, you can create another app, and you can assemble this app, and you have, for instance, about the documentation. You can retrieve the documentation from the customer, and then you can build just a rich pipeline. So this is just a piece of the claim processing.
Thank you. The next question is, how is such a system deployed in production? Which stack does it use?
Okay, it's deployed on Hugging Face space. You have the dress for instance, in the slides, also in the channel of the PyCon, and from my GitHub repository. And what happens that I deployed on Hugging Face using Gradio, so simple deployment, easy deployment, not sophisticated deployment. So to put in production require much more work. So it's just a prototype, for instance, but I think that it works. And it used, as I said, Python framework, essentially.
Thank you. The next question is, why do you consider the agents more transparent? How do you explain 78%, for example?
Okay, exactly. The question is interesting. Okay, what happens? What is the reason that I consider much more transparent? Pick up a deep learning model, a convolutional neural network. Okay, it's fine. It's the state of art of some years ago. It also can be used now. But you have a deep learning model that is a black box. The agent inside you have the LLM or visual LLM is a black box. What is the gain that you have between the previous system? You have the React loop. You have the summary of each action taken by the agent, the reason, thought, the action, so the calling from the API, and then the observation. So you have each step is just documented. So just you have the movement of the agent. Yes, inside. I agree, it's a black box, but it's just an upgrade despite of this convolutional neural network. What happens about the scoring at 78%? The threshold is 70%. I put is a general model with a computer vision from GPT 5.2. You can improve your accuracy with a fine-tuning model. Just, I think that is good with a generalization model. You have it is used in a zero-shot learning way. So it's good for my opinion. It's good, but it can be improved with fine-tuning model. Yes.
Thank you, Claudio. The next question is: given the flow seems very linear, have you tried to compare the multi-agent architecture versus a prompt flow-based architecture? If so, where do prompt flows fall short in your experience?
Okay, if you, I haven't done just I created the pipeline at the beginning, just a linear flow, and then I haven't now to watch, but what happens that you have just description. You don't have. I haven't the classification of the severity, and I have just the range of the cost. So the next step that we did this app is much more informative than the previous. Depend. You can build just with a flow chart, but what happens that is not adaptable with the context. If you use the computer, the vision agent, and the vision agent give the information that is vague. With a flow, simple flow chart, this information is passed to the cost agent, and the cost agent doesn't have the opportunity to improve the information. This vague information is spread into the downstream, falling into the cost estimation. Instead, with this multi-agent system, the opportunity is much more informative, give the classification. So if the failing about the cost vision in some for instance, give a vague description, but give a classification, the cost agent is reason about which type of the cost estimation to do. For instance, if it's a severe, decide to give a detailed cost estimation. If instead is a moderate or minor, decide to have a light estimation. So there is only one loop, but if you improve with much more loop, you have a reasoning. So with instead of just a flow chart, you have one shot, you have the result from the API, and if it's good, okay, otherwise it fails. Instead, in this way, you can have the loop that is able to reason by the agent and understand what happens inside the system.
Thank you so much, Claudio Giancaterino.
Thank you.